Hello, today we're going to take a look a little bit more at 5.5 Part B, where we're going to be using a U substitution to take our integral, and then we're also, since we're going to change it to a U substitution, we'll have to change the limits of integration here, which are x. We'll change those to U values as well, so that we can plug them into our U substitution. So let's take a look at our first one. I've got the integral from 0 to 2 of 2x over the square root of 3x squared plus 4 dx. I'm going to let U be what's under that radical. So if I say that U is 3x squared plus 4, then I know that du is going to be 6x dx. Okay? So for this one, well, I want to have a 6x. I've got a 2x dx. So I definitely, to get 6, I'll multiply a 3 in here. And remember, if you multiply 3, you have to divide by 3 on the outside to compensate. And so let's see what we've got now. So I've got 1/3 times the integral. And what I have is u to the negative 1/2 power, since it's in the denominator there. And then 3 times 2 is 6x dx, which is exactly my du. So I have what I need. Now let's think a minute about those limits of integration. I'm going to change those into u as well. Well, if x is equal to 2, then what is u? Well, if x is 2, then u, I can look right back up at my u substitution. It's going to be 3 times 2 squared plus 4. So that's going to be 4 times 3 is 12, plus 4 is 16. So this will become a 16. And my bottom, I have x is 0, so if x is 0 there, plug it into that u substitution. That would just be 3 times 0, 0 plus 4. So u would be a 4. And so what I've done is change this using a u substitution, and I've also changed the limits of integration to u as well. And that way I can plug it in for my u when I finish. Let's find the integral. So that's 1/3. Raise your power. That's going to be u to the positive 1/2. And then times 2. And we're going to take that from 4 to 16. So really I have 2/3. And then I'm going to plug in my numbers. Now this is u and 16 is a u. So I can plug it straight in. That's going to be 16 to the 1/2 power, which is really the square root of 16, minus, and then plug in our 4 for u. So that'll be 4 to the 1/2 power, the square root of 4. That's 2/3 times 4 minus 2. So that's just 2/3 times 2, which is 4/3 for that first one. Let's try another one. Okay. Our next one is going to be an integral from 0 to the natural log of 2 of e to the x power over 1 minus 3e to the x dx. Again here, when I take a look at this one, I'm going to definitely want to try a u substitution. I'm going to let u be that denominator, 1 minus 3e to the x. And when I take the derivative of u, that's just going to give me a negative 3 e to the x dx. Alright, well, I've got e to the x dx. What I need is a negative 3. So I'm going to multiply a negative 3 here to get what I need. And if I multiply by negative 3, I better divide by -3, or multiply by -1/3. So what I have here is a -1/3 times, if I write it in terms of u, I'm going to have du, which was -3 to the x dx, over u. Let's go ahead and take a second and change these limits of integration also into u by plugging in. So if x is the natural log of 2, right, if x is the natural log of 2, and I plug it into this u formula, I'm going to have 1 minus 3 times, well, e to the natural log of 2 is just 2, and so my u is going to be 1 minus 6. So here u would be a -5 for that upper limit. And I want to also find what that lower limit of integration is by popping in a 0 for x. So if x is 0, u would be 1 minus 3 times e to the 0 power is 1. So that u is going to be a 1 minus 3, which is -2. Okay. And now we should be able to take our integral. -1/3. Well, the integral here, du over u, that integral is the natural log, right, of u. So that's going to be the natural log. Remember, it's the absolute value of u, right? And we're taking that from -2 to -5. And now we can just plug in. So first pop in that -5. When I take the absolute value, that's going to be the natural log of 5. Minus. And then when I pop in that -2, that's going to be the natural log. Well, the absolute value is +2. This is what I'll have. So a -1/3. Remember, there's a rule with natural logs. When you subtract the logs, that would be the same as the natural log of 5/2 division. That's an old rule. This is okay. There's nothing really wrong with this answer, but it is possible if you wanted to bring that power up. This is a log. I mean, the fact that it's a negative power would be a reciprocal, and that 3 in the denominator means it's a cube root. So I could write this as the natural log. I'm going to go ahead and take the reciprocal. That's 2/5. And again, it's a cube root. It's just one other way of writing that solution as the natural log of the cube root of 2/5. Either way really is pretty good. All right, let's try one more of this type. Here's our next one. I'm going to go from pi/8 to pi/12, and we're going to take the integral of 2 sine of 4x dx. Okay, let's pick a u substitution. I'm going to let u be that angle. So if u is the angle 4x, then I know that du is just going to be 4 dx. Alright, so I have a 2 dx, but I want 4 dx, so I need to multiply a 2 in there to make it 4 dx. If you multiply 2, you'll multiply that 1/2 outside. Okay, so right now I have 1/2 times the integral. When I change it to u, I have the sine of u. And then I have 4 dx, which is my du. Let's go ahead and change those limits of integration into u, because right now they're in terms of x. So if I look at pi/12, if is pi over 12. Let's see what u is. U is going to be 4 times pi over 12. And 4 times pi over 12, though the 4 cancels into the 12, that would leave me pi over 3. So the u, or the pi over 12, becomes pi over 3. If I look at the pi over 8 for my x, if x is pi over 8, let's see what u is. U would be 4 times pi over 8, which will give me pi over 2. And now we're ready to go. Let's take our integral. Let's think about it. Well, I'm looking at cosine, but the derivative of cosine is negative sine, so it looks like I need to put a negative in there, right? And we're going from pi over 2 to pi over 3. So I have a negative 1/2, and then let's go ahead and plug it in. So I just pulled this negative right out in front. So I'll have the cosine of pi over 3 minus the cosine of pi over 2. Let's see what we have. Let's see, the cosine of pi over 3 is 1/2 minus the cosine of pi over 2 is just a 0, all right? So really I have a negative 1/2 times 1/2, that's negative 1/4.